Good afternoon, everyone. Welcome to the Digital Food Series today. We are delighted to have today two guests, Karel van der Velde and John Hertz from the Nijsen company. They are the pioneers in the realm of sustainability, turning food waste into animal feed. So today we will explore how digitization and the AI can be integrated into this circular economy model, not only to enhance operational efficiency, but also to combat climate change. To start, I would like to introduce myself and the Digital Food team. My name is Tiffany Tui. I'm the host of the Digital Food series since 2020. I'm a green development strategist and consultant. Other than hosting the digital food platform, I'm also managing partner at the Vertical Farm Institute, where we focus on developing sustainable ultra short chain for cities. The digital food team here present are Dick Veerman, who's the founder of Foodlog, and Anushka Anand, who's a writer editor at the Foodlog. We developed the concept of the digital food series to focus on the theme of connecting. So connecting data, technology, and strategy, and connecting people, ideas, and regions. So our key questions we would like to answer with our series is to discuss how do you convert digital solutions into value model, and how does it enhance sustainability challenges. And the key question involving this quest are what is needed to create trust among the connected players in the agri-food system, and how do we define value allocation models for providing data, transforming them, and applying information throughout the entirety of the food chain. So I have two guests here, as mentioned, and Nijsen, you are a leading company pioneering in converting waste into feed. So you've already been working on this circular model, connecting different players in the supply chain for a very long time. I have two guests here. John Hertz, you are the managing partner director at Nijsen. So maybe tell us a few words about yourself. What do you do at Nijsen, and how has the industry transformed since the time you were here?
I came into the Nijsen about 10 years ago with no background in agriculture. So I'm an economist and information technology. So for me, this world was very new. But what I have seen changing in our business is that we, let's say, sustainability and the shift from price competition to a value proposition is now, let's say, really starting up.
Okay, so before we go into, maybe tell us, I would like to ask you you are presenting first, right, about the history and what Nijsen stands for?
Yeah.
So before you start, I would like to ask, get the temperature of the audience. We have quite a lot of registrants from all over the world, actually quite a number of from Africa. I don't know if they're all present. So it'll be really interesting to hear the perspective from both the European and, let's say, emerging economy perspective. So let's ask this question first, Anushka, the first poll question. So the question is, what percentage of global food production do you think is wasted or lost each year? Do you have 5 or 4 choices? So when you are still thinking about it, John, what is your answer to this question?
I think better. What do you see? What percentage of global food production you think is wasted?
Globally, let's talk about globally. We can go into Europe.
The numbers I have in my head is about 30 to 35%.
Okay, 30 to 35%. Yes. Yeah. If the audience already finished answering, we can see the results, Anushka. Okay. That yes, most people actually, according to this number, can have difference depending on methodologies. But the UN surveys about 1/3 of global food are wasted. So, Carol, where in Europe, how much waste are you processing?
Well,
helping solve this problem?
We as a company are processing approximately 100,000 tons of farmer foodstuff a year. So that's directly coming from the food production system.
Mm-hmm.
And apart from that, we are also processing some 60,000 tons of what we call commodities, that are more the raw materials that are there as a co-product of the food production system. And these co-products are more common to be fed to farmed animals instead of the farmer foodstuff Nijsen is processing.
So you're a sizable company, so you process by 100,000 tons. So what percentage are you reducing, let's say, of the 1/3 of total waste? Do you have an estimate?
Well, then you have to create some borders within we are operating. So let's give me some context. In the Netherlands alone, every year some 320,000 up to 350,000 tons of farmer foodstuff are being processed in animal feed. And we are processing approximately 100,000 tons. But that does not mean that all our resources are coming from the Netherlands alone. We are actually sourcing all over Europe our products.
But let's safely say, despite your large, very sizable amount you're processing, there's still a little drop in the bucket, isn't it? Or compared to the total waste of food that goes into landfill or just wasted or from food ditch. So
that is true, Tiffany. As you already had in the poll, from every 3 calories we are producing to be eaten by humans, only 2 of these 3 are arriving the consumer. 1/3 is not. And to create a little bit a bigger picture, in Europe we do have some more numbers on this farmer foodstuff part. Approximately some 3.5 million tons of farmer foodstuff are being processed in animal feed annually in Europe. And the Netherlands is then 350,000 tons of it. But that's only, once again, the farmer foodstuff part.
So we have a lot of work to do globally, but please tell us a little more in detail. What do you do? Floss, you are strong.
What we more do is first, let's say we are what you say. We are a small family-owned company, and for about 35 years now, I think 35 years ago we started processing farmer foodstuff more or less by accident as source for feeding animals, especially pigs. And that in those 35 years we evolved, let's say, from small scale to an industrial scale in processing those form of foodstuffs. And it's about, let's say, I always say it's about 400 to 500,000 kilograms a day. And it's about 2,300 to 2,500 different kind of products, packed, unpacked, in all kind of packaging, or they come in crates or pallets or in containers. So it's a very complex and intensive process to process those form of foodstuff. And in the, let's say, we make the switch to let's say to a traditional feed company to a more circular feed company. More or less, let's say, about 8 years ago, we fully focus on the strategy to deliver, let's say, the feed with the lowest carbon footprint in the world. That is our aim. That is what we do. And so, as Karel said, we source from all over Europe, but let's say our customers are, let's say, based in approximately 200-300 kilometers area. So we are very international on the former foodstuff side, and we are very, let's say, locally on the feed side. And what also is changing is that for 10 years ago, we saw, let's say, the farmer as our primary customer, but in the last years, we focus more and more on, let's say, an ecosystem-based marketing program, and we make connections with the retailer, with all the parties, not only in the supply chain, but also, let's say, other stakeholders like NGOs and government and intergovernmental institutions. There's a bit of the transformation we made the last 10 years.
Yeah.
I think it's so based on that and on the question about the digital food and how Nijsen does it is we composed a presentation, and I will give a little introduction into the let's say data driven Nijsen is becoming to succeed in this mission and strategy. Doe je dat zelf doen of niet? Ja. Here you see it's who is Nijsen. We are a formerly feed company, just like all here in the Netherlands, traditional. What you see on the left side is more or less a roundabout telling the story about the collecting the former food stuff from the food industry, about 2,300 in all kinds of containers it comes in. And we created more or less a visual roundabout to tell people what we do with it. If it enters the roundabout, we process it and we look from the waste streams which exit is most suitable for the waste stream. It can be the traditional husbandry, like pigs or chicken or cows, but also can be pet food or even wildlife. We're also into insects and in bacteria, and also in what we call soil life. And we're also looking at let's say, non-animal applications like green energy. And we also are trying to use, we have a lot of waste ourselves, the packaging material we collect from unpacking the goods. We'll try to give it a second life. So the left is, let's say, telling more what processes we do and how we look and try to evaluate those waste streams and create circular systems. And you can imagine that every exit can be connected to another exit. So insects can be a protein source for pet food or for pig feeding. Also can be the bacterial side. So we all and let's say the manure of chicken can be part of the soil solution application. So we try to make all kinds of connections to create circular concepts. And on the right, you see a more visual of how we try to do it. We connect also with let's say with retail brands, with retailers, and the supplier of the retailers who bring their food waste to Nijsen. Nijsen makes circular feed, is be fed to animals, and the meat, eggs, and it goes back to the retailer. And this kind of closed loops we are trying to establish more and more, let's say, here in our world. If you look at how we use data, data is becoming, like everywhere, more and more necessary to it. So I first start with how we use data for our internal process. It's a bit traditional, but as we know, we are much more complex as a feed company than a traditional company, because it's hard for us every day or every week from what comes in, when comes it in, how does it come in, which quality is it. So we do a lot of things to predict that kind. Also, apart from a traditional feed company, there is no relation between the input and our output. A traditional feed company predicts his output and then orders or places his and buys grains and wheat. We have to look at the industry, what is their waste. The second thing, what makes it very complex and we need data very hard, is we have to have a very high turnover rate of our input because the shelf life and the quality is degrading per minute. Instead, we are, let's say, we have very highly automated processes. The machines are very, let's say, connected to each other, but we have to handle also a lot of irregularities. So it's a very hectic and complex environment we have to produce. So therefore, we start some, let's say, data-driven, data-based solutions to tackle that complexity. One thing is we are collecting all kinds of data from our sourcing locations. So we know ahead about what is coming, when it's coming, what quality it is coming, and we also give feedback on those on our deliverers, on our suppliers about these data. The second thing we are now doing is we're starting more and more with robots, and robots are also let's say automating the process because they already have when they pick, for instance, they already generate information and data about the product, and that can be used to optimize the production planning. Maybe you can imagine that our transport and production planning is very hectic because of all those irregularities and, let's say, less predictable situations. So we use a lot of data, and we need a lot of data to, let's say, optimize and to make the right decisions to make between what it cost, the cost, but also about the quality, and also about what we need. So to optimize that dilemma, we need a lot of data and a lot of fresh data. And of course, always important in the food and the feed is you have to track. Because if something is wrong, if something is, we have to act. So tracking and tracing and acting is essential for Nijsen. The next step what more companies are doing, we are stepping into artificial intelligence. So we are using now vision technology to enhance our quality system. We have a project that's called the Autonomous Factory, in which we want, let's say, like the Tesla, to make our feed factory human-free, so it can produce autonomous, and we use that for artificial intelligence. We also use artificial intelligence for, yes, I call it fast programming, because of the options you have and the technology now available. You can make your own applications very fast with the use of AI, for instance, ChatGPT. And of course, we're using ChatGPT for marketing manuals and questioning and answering our customers. Maybe the most interesting part is about is the external side of our data-driven business. Because if we move to circularity, the shift of let's say data also shifted to another viewpoint. And if you go to share, it's because we say we are not selling things or services, but we are selling results. And that's therefore you need data, because our customer wants results. He's not interested in things or services. So I call the circular economy, for me, is an outcome economy. And the outcome economy is a data-driven economy based on sustainable value creation. And that's a major shift in our business. It's about data-driven sustainability, but also about value. And this means that our marketplace is changing, where we have to compete on the ability to deliver quantifiable results that matter to the customer. So it's also very important to think about who is your customer and what does he want and how do I make it quantifiable. and that whole question, answering that whole question, you need data. If I go back to the meaning of quantifiable results that matter to the customer, that means you have to establish cooperation, and cooperation based on the same target on value creation. The second important thing is you have to create trust. You have to stretch your business boundaries, because you have to think about more than your four walls. One very big thing is it's not talking about supply chains anymore, but you have to think and talk in circles. And another thing is also the business needs an end-to-end digitalization. That's an how do you call it? Voorwaarde and yeah,
represented.
Yeah, it's needed.
Yeah.
So what do we do to answer that question? Is you have to think about, it has to be the outcome economy. The circular economy says it has to be quantifiable, and it has to matter to the customer. So if you realize, what we realize is that 75% of the carbon footprint of a retailer is in what we call the scope 3. So if a retailer wants to reduce his carbon footprint or wants to do something about his sustainability, the biggest opportunity is in his scope 3 targets. And they are called science-based targets, so they have to be scientifically data-based. And as we are at the start of a supply chain to the retailer, and feed is a major component of the carbon footprint of, let's say, meat or animal protein, there is a big opportunity to answer the question of the retailer, please help me to reduce my carbon footprint. And to do that, we have, let's say, that's because it's a scientific based target, you have to come over with quantifiable results, just not with small talk, not just with greenwashing. You have to come with concrete, very specific measures to deliver that contribution to those reduction of the carbon footprint. And as an example, how we did it is, for instance, is we did with the LCA and all kind of things. But let's say that's more the field of expertise Karel has. So I will give it to Karel.
Okay, thank you, John. Maybe we can take a little break here. As you are starting already mentioning the topic of scope 3 and LCAs, I think we should maybe also explain a little bit for if anyone is not clear about when we talk about scope 1, 2, 3. So maybe a few words, John. What is scope 3?
Scope 3 is there is an organization, it's called the Science-Based Target Institute Initiative, who said it's all good about talking about climate change and actions, but make it quantifiable, make it science-based, and make it quantifiable. And they determined for a company 3 scopes. Scope 1 is what can you do by yourself, and so it's more or less, let's say, in carbon emission. What carbon emission do you produce by yourself? If I look at Nijsen, we use fossil energy. We have car trucks, and so this is the carbon footprint you do by yourself. Scope 3 is scope 2. That is logistics. That is the carbon emission produced by the logistics. So the movement you have with your company. So scope 1 and scope 2 are more or less in your own, let's say, field of influence.
Right.
Scope 3 is the carbon footprint you get from your suppliers. So if I look at a retailer, when he has 20,000 articles in his assortment, he is importing a lot of carbon footprint by selling those 20,000 articles. So, for instance, as an example, a retail outlet, the retail outlet itself has a scope 1 carbon footprint by his light, heating, cooling system, has a scope 2 by his logistics from inbound and outbound logistics, and his scope 3 is all the products he has in his shelf. And so what I'm saying is for instance, for retailers, they have committed to reduce their carbon footprint. So the biggest opportunity is talking with their suppliers to deliver goods with a lower carbon footprint.
So we know that that's very clear. So that means basically that the big companies, especially retailers, for example, cannot say like, how the products produced or how the pigs are fed outside of my influence. In fact, they have to be made responsible for sourcing their product. So that makes also let's say, putting this environmental impact to actual responsible parties. So that can be the consumers, but also the big processors and the retailers. And when we talk about carbon footprint, of course, the animal production is an environmental impact. It's really at the, let's say, especially if you're in the Netherlands, that's probably one of the hottest topic. And we know that the food production, the entire food system, contribute to about 1/4 of the total global carbon emissions. And animal production, do you have a number of this 25%? How much is animal production, the chain, responsible for? The entire scope 1, 2, 3? Do you have
by heart, it should be somewhere around 15%.
Of the total?
Yeah, of the total.
Okay. So, of course, that's a big topic, especially I think Dick has probably a lot of things to say as we are at the hot debate issues in the Netherlands. The animal production is facing a lot of changes. So maybe you also can tell us a little bit, where is this industry going, how we can help with the overall sustainability and carbon emission of the entire industry, because it has to do with the survival of the sector, not?
You're asking me, Tiffany?
Yes.
Well, obviously, this concept of circular feed reduces carbon, so the scope 3 to 0. So it's very important to reduce the carbon footprint of meat. And obviously, we need to distinguish the meat and eggs that come from a system like this from a system that is fed by wheat and soy, for example. So in the end, this is a huge opportunity, especially for the Dutch industry that produces a lot of food waste, to renew the concept of meat and dairy and eggs as actually a sustainable industry. And we aren't used to that idea. So turning around the idea that meat and eggs and dairy is bad depends actually on communicating the idea that using food waste as circular feed is very important, and it produces fertilizer, of course, like dung. So it's very important that we communicate right what we are talking about here, and it reduces scope 3 emissions to 0 if it is done well.
Do you see this kind of perspective, science-based data, supported by data, is being communicated and converted into a political process that will happen?
No, not enough. Well, so chickens fed by Nijsen feed are kipster, and kipster is like a hipster in the Netherlands. So that it's an accepted, I think, concept of eating eggs. So that works, but I think it should be done more.
On that note, let's ask our audience the second poll question. Anushka? Anushka? Ah, good. So question number 2 is, how much do you agree with the following statement that, as John already briefly touched upon, and Carol will elaborate more, is that the digitization and use of AI in animal production can significantly reduce the industry's environmental impact and the carbon footprint. Do you agree or disagree? Do you think that's not going to make a lot of impact? So, Carol, what is your answer to this poll question?
Well, obviously, I do agree. As John already explained, it's all about data, and to be avoiding, let's say, greenwashing on this topic, you have to use data to underpin and underline the statements you are making as having circle feed contributing to lowering carbon footprints.
But the challenges, there's a lot of promise by AI and data, but there are also a lot of challenges, isn't it? That indeed this greenwashing is still a big concern, whether the scope 3 and the new target is just a new form of washing. So maybe tell us, how is your technology and AI and data can actually help achieving this trustworthy insight and track and trace?
Well, to elaborate a little bit on the role of AI in this, what we have learned until now, and I will elaborate on that a little bit more shortly, coming up with these data is not that easy to do. It's quite a complicated process of looking where is, for instance, energy used in your production process. And at the same time, you want to be as exact data as possible. So I do think there is a role for AI in the near future by measuring all along this production chain, even along the food production chain itself, incorporating, let's say, on farmers level, the information and combine it into a carbon footprint that comes along with this product that this farmer is producing. And that's something I do believe AI can help us a lot in, on making that more easy by using the already available data and using the maybe to be designed or already designed methodologies you use in order to calculate this LCA in the end.
Okay, so before you start, let's see the audience. What do we see, and what do our audience think about the potential of AI and data? Anushka, if you have yeah. Okay, so well, most people do see a big potential, the positive influence of data and AI that actually can help us in managing our environmental impact, right? So, Carol, the floor is yours. Please tell us with your examples of how do technology help us in this aspect?
Yeah, okay. Therefore, I have come up with some slides to explain a little bit what is happening and what you already know and what you would like to know. And I would like to divide this chain of food production into 3 parts. The animal, because we are into the production of animal-based products. The raw materials that are needed to feed the animals, because obviously they do have to eat in order to produce. And in the end, the menu, or what are the animals exactly eating, and what does that tell us about this carbon footprint reduction or possibilities. And first of all, you have to start collecting data on a farm. And at this moment, someone has developed a system in which that makes it much easier to follow the data, to have the data following the animal. In this case, I'm talking about a method in which you are using ear tags that are equipped with RFID chips. And every treatment you are doing with this animal or any development that is taking part along that animal is being recorded. And all this information is being stored on farm and into the cloud, and is possible to share with parties within the food and feed production chain. So actually you already have your first step on gaining data and gaining more insight in this production system on farm level. And of course, it's not only everything that is happening to the animal itself, it's also in the way it's being housed. What type of stables are you having? What type of ventilation system are you having? How much energy is needed to run this farm? All these data can be gathered also using sensors and therefore stored into the cloud and being used in the end on calculating the carbon footprint. So it all starts with data collection on the farm. Otherwise, you have no starting point, so to say. And that's something I showed you in this picture. If you look into this chain more carefully, it starts all on the farm with arable, plant-based products and animal-based products. These are being transported to the processor, let's say the food processors. They could be either dairy processors, but also slaughterhouses and meat processing plants. And in the end, all these products are being transported to the consumer. So having this data gathered on farm level, then we also have to understand that we can use this data also to improve management techniques on farm level. You are actually helping the farmer to be more in control on his production processes. Maybe some of you have already heard that precision farming is taking place and taking its first steps in development. And that's also something that you are actually seeing over here. What does an animal need? What does a specific service need in order to be producing more optimized? And this data is therefore not only used as a method or a instrument to tell something about, let's say, the carbon footprint, but also to help to enhance the management on farm level or any other place where we are producing. Secondly, the raw materials, actually the scope 3 part of Nijsen itself. What are we using in order to create feed for the animals? Obviously, the form of foodstuff we already discussed, but apart from that, also the other co-products that are derived from the food production system. And these raw materials, you do need to know exactly what it is, where it's derived from, but also how it is produced. And what you see right now in this screen is actually that we, as a feed sector, have come up with what we are calling the PEFCR feed for food producing animals. And the PEFCR stands for Product Environmental Footprint Category Rules. What you are actually saying with this is we are looking into the scope where we are where we are part of. That is, from the moment the raw materials are being produced on arable land, along the logistics towards the feed compounder, and in the end brought to the farm. And then obviously of the farm, the animals are fed with this feed and therefore contributing to the carbon footprint of these animal-based products. But if you look more closely into this process, what we have done is we have looked into on what places is energy put or are products used in order to be able to produce these raw materials. And it's actually quite easy. If you are, let's say, producing cereals, it starts with, in our area of the world, the tillage of the ground. After that, sowing takes place, fertilizing takes place, and sometimes even irrigation takes place. All these processes have to be mapped in order to be able to address the amount of energy and other efforts that are there, that are contributing actually to the carbon footprint production, to the CO2 production, directly or indirectly, of course. After these products have been harvested and in some cases processed in order to create food, these co-products are brought to the compound field to be used in feed. And there you have the first allocation step. We are actually allocating which part is going to the feed, which part is connected to the food production. If you would take, for example, the production of bread, the wheat that is being used, and it is grinded, and if you are, in this case, producing white bread, we take out the gluten of the product. This allocation is taking place on the amount of the main product, the wheat, which part is going to the bread, and which part is going to the feed. And we have made and we is not a Nijsen company, but the feed sector, we have made a distinction on how to do this allocation, how to perform this, and that is based on economical allocation. Because in the end, we are in the business of food producing in the food production system. Therefore, your main product has the highest value, and your co-product or your waste product has a lower value. And in order to address this carbon footprint emissions, we have used the economic allocation as the method to address and to take into account where the CO2 is produced and where it has gone. The last step then, what we are doing is creating the menu for the animals. Since we as compound feeders know exactly what animals do need in a certain stage of their certain phase of their life, we can create the feed that is needed for them to feed them correctly. But therefore, we also do need to know what actually on a nutritional level is available in all these products that we can use in our feed mill. So a lot of data is being generated in researching on what the quality of raw materials are. That's been done on a chemical analysis, but also in vivo analysis. So feeding it to the animals and then gather the data in to what extent these products are being digested. All these data are being gathered and shared on a continuous basis. We as a company are looking very closely into the raw material we are using in our processes and analyze them. The same goes obviously for the farm food part of it. These data are being gathered and used by our nutritionists in order to design the feed in the end. That feed has to live up to all these demands of this animal. And you can imagine that a young piglet does need a completely different feed from, let's say, a gestating sow or a fattening pig. And that does mean that actually, if we are looking to the pig farmer, we can provide him with 7 or 8 different types of feed that are actually exactly fit to be used for his animals. And if we start to create such a feed, something like this pops up on the screens of our nutritionists. In this, you can see a composition of a feed on the left-hand side of this picture. You see something like, it's called in Dutch tarwe or wheat, and it has 35% part of this feed. So barley comes into it, then the product we are producing, this deegmelange, and so on and so on. And you have to understand that behind this line of, let's say, this wheat, of which 35% is used in this typical feed, maybe up to 80 different nutrients are calculated within, are used to calculate into. Not only like minerals or energy or fibers, but also amino acids, or even some attribution advances on the intestine level of a pig. All these data are being used to, in the end, come up with a feed that lives up to the demand of this pig you are creating this feed for. And of course, we are using the carbon footprint data in this as well. And if we are talking about carbon footprint, it's not only the CO2 equivalents we are talking about. In this methodology that is called the PEFCR, we are actually addressing 16 different impact categories on which the feed has on the environment. So it's not only the CO2, we are actually using CO2 as a container, call it, to address the total effect of the feed on the environment. And that makes, I hope, clear how complicated it is and how important data are for not only this feed producing, but also on farm level, knowing how much carbon footprint is, how much the contribution to the carbon footprint is. And in the end, the animal who is selling his animals or his animal-based products to the processor downstream can give along all this information. So the on-farm data and the feed data. And with all this data, the food system can act and give more information to the consumer in the end. What does that mean? We have done some research on that, and we looked into what you see here on the screen. What does it mean for a fattening pig if you are feeding it with, let's say, a more traditional feed, a feed that is being liquefied or liquid, or a feed that is being called, what we are calling 100% circular. And then this last example, with the use or without the use of soybean meal. And it's not that sharp, I see on my screen, but let me elaborate a little bit on it. We have only looked into the part or for the fattening pig, and that does mean we start at a piglet from 25 kilograms and we end with a fattening pig that has a slaughter weight of approximately 95 kilograms. That corresponds with a pig that weighs approximately 125 kilograms when still alive. Then this pig has been fed 240 kilograms of this liquefied feed, this wet feed, and that's been recalculated back to 88% of dry matter because the LCA is being performed on the unit 1,000 kilograms of feed of 88% of dry matter. Then you have this 225 kilograms of what we are calling solid feed with the use of soy, because we do need some proteins in this feed. We have compared that with also a 100% circular feed called solid without soy. We left out the soy and we used some alternatives for that. And that we compared with 240 kilograms of this traditional feed, which our competitors are actually using to feed these animals. And if you look more closely into the picture, you see that's a great variety. What does it say? The bar on the most right-hand side, it is your traditional fat pig. And this fat has been eating a feed that brought along 217 kilograms of CO2 equivalents. So this pig, in this period of 25 kilograms up to 125 kilograms of weight, has been eating feed that has a carbon footprint equivalent of 217 kilograms. If this pig was fed this 100% circular feed without soy, this number would be as low as 102 kilograms of CO2 equivalents. Therefore, the immediate effect of having a circular feed versus a traditional feed is a reduction of over 100 kilograms per fattening pig in this period it's fed. So there you have actually quite some impact that is there. And we are able to calculate this because all these data that were gathered. So maybe I should stop here because I gave quite a lot of information, Tiffany, and I can imagine some questions are there.
Yes, indeed. That's as we're talking about data, I think there's already some questions because there are measurements quite very accurate about the CO2 equivalent emission. For example, we know beef is really the worst, about ranging from 15 to 26 kilogram CO2 equivalent per kilo. And pigs is better, about 2.4, approximately the same as the chicken. So just to clarify, your data shows here, it calculates per pig the complete life cycle carbon emission, whereby a circular feed can reduce the total by 50%. Is that what we're looking at?
Yeah, exactly. That is what you're looking at. At the time we made this research, the exact unit in how to communicate on carbon footprints was not determined yet. Actually, it is still not. On feed level, we have the unit 1,000 kilograms of compound feed, but on animal-based products, there has not been an exact unit formulated yet. That is still to be defined.
Okay, but if we just make a very rule of thumb, kind of a rough calculation, if you can say, well, by a circular feed, we can reduce the CO2 by 50%, that will bring the pork per kilo down to, let's say, 1.2, which makes it even more efficient than the current fish, for example.
Exactly, yeah.
That will make actually a lot of potential impact in terms of policy making, no? If you look at the overall policy regard.
And that is exactly why we do need this data to explain to the people and also to the consumer that these eating animal-based products, as long as they are fed circularly, so with, let's say, waste streams or residual flows, you're actually contributing in a lower carbon footprinting of the food production system. But at the same time, you have to understand, you cannot feed all the animals with these waste streams. You can only feed them as much as these waste streams are available. You have to be aware of that as well, obviously. And in the end, then, on a policy level, you have to determine, are we eating more animal-based products? And therefore, you have to grow biomass to feed them. And you are competing with food. Or are you stopping with this point that you say we feed only these animals let's say, these residual flows, wherever they are coming from.
Yes, I think it'll be really interesting. Now we can go into our session on discussion of your future development and also application, let's say in a bigger global scale. Because I remember actually visiting Nijsen about 10 years ago with a group of Chinese delegations, Chinese government, entrepreneurs in developing agriculture policy and agri-park. So we know that the developing world or emerging economies are facing different challenges as a mature economy. In the West, basically, meat consumption and production need to go down. There's a trend of a consumer switching to more vegetarian-based diet. But in emerging economies, protein production and consumption need to go up. That certainly is true for China, India, and Africa. But of course, in the kind of societal or the regulatory environment is different. In, for example, we just talked, for example, Africa or China, there is no yet scope 3 consideration. So the driver will be different. And the question would be certainly that also the kind of a distribution in global food waste is also different. In developing country, most is post-production, lesser on the consumer side, whereas in West economy is mostly more on the consumer side, for example. So, and you are developing a model really kind of is more like our electricity system, also facing similar transitions. So instead of demand driven, you are planning based on supply, based on resources. And so what is available and you produce in some ways, kind of smart grid system for, let's say, food waste in some ways. So there's a lot of synergies to tie into different areas in smart cities, in emerging economies. So I'm very curious to hear you and John to think about the future. What might be? Can you give us a glimpse of where are you going for the future? Transitioning from a feed company to a data company, essentially.
Yeah. Well, that's a very good question indeed. What you are describing is that our food production system is still evolving. Parallel to what's happening with the growth of the world's population, but also on the effectiveness of it. And what we also do see, therefore I would like to explain this picture. In Europe, we already have what you are calling a mature system, and at the same time, it's not a very efficient system. Some time ago, 20 years ago, we have decided, all the politicians, to ban animal-based products out of the feed production chain. And it was because of the BSE, the African swine fever, and the foot and mouth disease issues we had back then in our environment in Europe. And these diseases were actually induced by feeding animals animal-based products. So politicians came up with the idea, let's ban this. By doing so, they indeed made it possible that these diseases were extinct. But at the same time, we were creating large volumes of food waste that were actually having a good nutritional profile to be fed to animals, but we were not allowed to feed them. Now we are investigating the possibilities, like is happening in other continents apart from Europe, to have these waste streams, these residual flows, re-entering our food production system by, after treating them in a proper way, as feed raw materials.
As Karel says, we are trying to open up more waste streams, but the second thing we are also doing is because we change, let's say, looking from what does an animal need, change our look from what waste streams are there, and which application can we find, and make let's say a digital twin of it. That also makes it possible to let's say export that kind of knowledge and to support, let's say, other regions in the world with our knowledge and understanding of transforming waste streams into other applications higher in let's say in the value chain.
An example of that one is now on the screen. What you see here is actually what we have been thinking of a next step of the protein transition. As the people might know, as viewers might know, ruminants are capable, because of the microorganisms in the rumen, to create protein by the fermentation process. And what is happening in this process? These microorganisms are being fed nitrogen and carbon, and they are actually designing or creating amino acids. And by doing so, they are feeding the cow. This process can obviously be copied outside the cow by using the same type of microorganisms and feeding them a processed water that we are having in the Netherlands, especially because we do have to rinse the air that is coming out of the pig barns we are having in order to lower the ammonia level of this used air. And by rinsing this air, you are actually concentrating the ammonia and therefore the nitrogen within this processed water. If you would collect this water and feed it to these microorganisms and you add some carbon to it in the form of, let's say, low quality residual flows from the food industry, like in candy that is being discarded, you are feeding these microorganisms carbon. And then these microorganisms are actually fermenting protein. Now imagine our dream. If you could design this in, let's say, in a container level, sea container level, a 21-footer, and you can put this next to the farm where this processed water is being produced, you can feed this container with this water. You feed some of this candy product to the bacteria, and then they are producing the protein, and you can feed actually this protein directly to the pigs on this farm. You don't have to have a supply from outside the farm anymore. We have been testing this, and actually it's being done already in the world, even on food level. Singapore is now feeding, or is making it possible to feed people this type of protein. And the quality of this single-cell protein is comparable to fish protein. So actually very good animal-based protein. So this is something what John was referring to, looking into the future, using data, using techniques, using AI, we are capable of enhancing and maybe speeding up this transition we do need in order to be able to feed the world the food. And if you do need animals for that or not, it can be done more effectively than we are doing right now.
Very exciting. Thanks, John and Karel. So I would like to open up the floor. We have quite a number of participants. So please welcome to just join in our discussion with questions, comments, and or any suggestions for how do we bring this kind of development to integrate with other sectors or other regions. Who wants to be the first?
Tiffany, I think we should take on Santiago's question. Mm-hmm. How much energy takes the AI? Obviously, new technology always uses lots of energy as protein. So bacteria-based proteins use a lot of materials, new materials, and all of that uses a lot of, will cause a lot of CO2 emissions. So what is indeed the scope of, what is the level of CO2 emissions by introducing new technologies? Data is one thing, building reactors is another thing. You need the steel, et cetera, et cetera. So let's talk about the emissions new technologies cause.
Yeah, of course, because the other side of the coin of let's say being data driven, you need a lot of data, and also you are very reluctant to throw away data, and all that data needs to be processed, needs to be stored. So that is a fruitful discussion now coming up. Yes, because it's virtual. Doesn't mean it doesn't take any. It has its implication on the environment. Let's say to be honest, we are aware of it, and we are also looking at let's say the most efficient or effective solution. But it's a hard and a tough question, because you also need it's a dilemma between the applications and the cloud things you need, and where it's distributed. So that's a really true question, and I don't have, let's say, the full answer on it. Only that I say is we are very aware of it and keen on the subject and try, let's say, to minimize also our data, to store not our data, let's say, in all those cloud applications.
And actually, they will be part of the scope 1, 2, 3 discussion we already had, because we consider this as scope 1 of a production process, this energy that is used to have all these data. So it's something we have to look into, not we as a company alone, but in the end, as a food production system, how can we calculate in which way this food production system is the most efficient, and what part AI can contribute to that.
And another thing is what we try to do is we try to be, let's say, at least our next step is also in scope 1 to be energy positive. That means if we can, let's say, do a lot of things locally, it will also have a positive effect on so store and process as much as possible on our local premises.
I think it also will have a big impact on the usage of the need for artificial intelligence. The more you decentralize or produce locally, the less information you will require. So I think that's a very good step.
Yeah, thank you.
I agree. Optimizing this production chain has a lot of potential, but we are still just at the beginning of it.
Thanks also, Pedro, for the comment. I actually would like to ask John, because you are in charge of steering the boat to new directions, and you mentioned you need to provide actionable, insightful data, which is value to the customers. Imagine your customer is also changing, or may have new customers, because the old customer are the companies that are raising, let's say, piglets, that has and now who will be your new customers?
That's one of the chairs. It's also a question we struggle a lot about with, for instance, with a new website, is that we say, wait a minute, if you say the customer is the one who pays your invoice, it's still, let's say, the farmer. But if you say the customer is who problems you solve, I say, for instance, we say it's the retailer or even the out-of-home market. A popular way of saying it is we sell also, let's say, good conduct, and so we see retailers and the out-of-home market as also as our customers.
Do you see that they will be paying you directly, or do you think that because retailers start to adding requirement to their suppliers, so that indirectly translates to?
Yeah. The biggest move we have to make is and I'm quoting Jan Rotmans, one of the professors in complexity. He said, "We are not in a period of change, but we are in a change of a period." So we are still, one of the greatest barriers we see is we keep still thinking in supply chain. We're talking about change. My mantra is, if we go to a circular economy, we have to use circular business model. And yes, at the moment, is the retailer is talking to and giving orders to his supplier, and so it's going backwards into the supply chain. And that's a very efficient way. We're trying to make the supply chain circular, and that in the end it will not be the solution, I believe.
So there needs to be a new customer actually directly paying for the value of data.
We need a new view on who's the customer, and we need a new view, a new paradigm on how to build business.
Great. So also like to audience, you have any idea, suggestion on who should be new customers, paying customers to this new circular model, please jump in. I'd like to ask Laura, you asked the question, maybe just introduce yourself and your question. If you can, turn on your microphone and camera. Yes, we can hear you. We don't see you yet.
See if I can put the camera on as well. start video. Let me see if it's working now. Yes, it's working now.
Yes,
Yeah.
we can see you.
Good.
Where are you calling from?
I'm calling you Laura Locatelli from DSR Firmenich. I'm working in sustainability. I'm joining you from Copenhagen today, from Denmark. So pleased to be in this discussion, and thank you so much for you sharing how you see this view, and very exciting really to hear your views on that one. My question is actually I'm fully support the idea that we need to cooperate and collaborate more across the value chain. Actually, how you see the difficulties, or how challenge is or has been for you guys to share data across the different across the value chain with different stakeholders, with the one producing those food waste and the one using it, and even with the retailers, because it's a complex thing and we need to find a way really. But I'm excited to see your view on that.
Okay, that's also a very tough issue, because from two sides I see it's both more and more companies or people realize the value of data, and a key player in role is, for instance, the farmer, and he sees his opportunity to get extra money, and the third is what I know, let's say at least about the Dutch things, the supply chain is a very low trust, at least over here. So sharing data is a very, very big issue, and I see two solutions are offered. One solution is a technological one, because to people say you get a data safe. You determine what kind of data to whom you release. The second thing I want to add to it is it's don't use the word transparency, because for one reason it's a more, let's say, philosophical. I don't believe the humans are ready for a transparent world. Second, I think we don't need a transparency, we need honesty. What we tell has to be true. You don't have to tell everything. As I say to myself always, I don't say to my youngest child where the sharpest knife is, and I don't know it. Don't say it to him because I hate him, because I love him. So that's about sharing data. I think we have to build some kind. That's why I don't talk about transparency. About we have to create and build trust.
And maybe if I may add, Laura, what I already showed in the picture, do not underestimate the value of the data for the farmer, as an example, himself, in order to optimize his production system. And that goes all along this chain. So it's always an ambiguous thing, this data.
So I think, Laura, there are technical solutions. And the second one is that's the mindset. There's a mental thing. Is if you are in a circular economy and in an outcome, the central piece of this is that you create in cooperation a central value for a customer. And if you keep that in the center, that is what you do in the cooperation, and that should be the goal. It is not, let's say, that's the mind shift in thinking about the new business model. It's about a mutual value creation.
I fully agree. If I can just add, Tiffany, on this, is a key thing, that the value for the customer, and it's also linked to what the customer is, because we are redefining here the customer. So making the definition of a customer and the value for this customer in a central part, this needs to be a win-win situation. Otherwise, I don't see the cooperation going on. So I fully agree that, creating the trust is the fundamental thing on the sustainability. Thank you.
Thank you.
Thank you. I think the issue with the customer is a difficult one, because we are talking about incorporating public goods. So creating public value, which is good for everybody, but who's to be paying for it? And then to get them paid for it, that's probably every business need to understand that. I'd like to invite maybe Fernando or Santiago. You asked a question about the CO2 reduction. So Caro gave a calculation, as we discussed, for pig anyway, can let's say reduce 50%. Are you happy with that result, or do you have other comment? Fernando, are you still with that? Yeah.
Sorry.
You're you're joining with us from Beulah, right?
Yes, I
Yes.
work for Beulah. I work for actually I'm leading with Beulah supply chain visibility projects.
Yes.
Completely agree with you, Laura, about trust is key when we are talking about all these projects through the supply chain. How to increase the trust between stakeholders, for me, is still uncertainty or unknown. How to increase that trust, I think for me is clear. The trust, we need more trust between them to share data, because without sharing data, all these projects doesn't have fit for food. No. How we do increase that trust? I'm still to find an answer for that. About the reduction of 50%, yes, I agree. I work nowadays I work in a CO2 traceability project through the supply chain, where we use our sensors and our completely connected mills to understand the CO2 energy consumption and CO2 emissions in the production. But what we think is key is that for us, so in our products, so the products we support our customers, like at the wheat production, that a byproduct is fit, around 60% of the amount of CO2 emissions in the supply chains are in the agriculture step. And that is a step that is not industrialized, where there is no sensors, and where we don't have data from. All the data we use is from tables, assumptions, and more things. So for me, for me, the challenge is how we address this agricultural step when we are talking about CO2 emissions, because for me, the part of processing and technologies, this is part of this. We have technology, we have sensors, we have data. How we address the scope 3 emissions on the agricultural of the raw materials. For me, that is the key question.
Yes, actually, really glad you can join us today, because that is we discussed the Beulah technology a few 2 months ago. You are developing indeed the whole sensor and traceability on the feed side. So in principle, you complete the other, not complete pieces of that whole complete supply chain to what the Caro is doing. So are your technologies talking to each other? Do you see that you can be working together to complete the puzzle?
Yes, it's something we can work in. We have to collaborate with the different people in the supply chain. No, we are not part of the supply chain as part of we produce any single product. We don't produce any product. We just provide equipment, and we are able to read the data. But yes, open to create new projects and new consortiums with different companies. But the thing is, for me, the thing is key when we are talking about sharing data and trust. Trust means share data, and share data means trust. Chicken and egg problem that I think I haven't came across with a proper answer to that question. And as well, who pay for it? It's a really good question. Yes, we create transparency, we reduce the CO2. Who's going to pay for it? I have my doubts if anyone is going to pay for it, if we are creating any value on the product, or just it's a cost that companies have to assume in the future. I used to think that there was an increase on the value of the products, providing CO2 emissions and transparency. Then the end customer, the consumer, is going to pay more for the products. Then we are going to get a new revenue stream on the supply chain that everyone is going to benefit for it. I used to think that. Nowadays, I am thinking more with the different regulatory we are seeing in different countries, European Union, and different things, we are thinking more, or I am thinking more as a cost, because it's something that is going to be compulsory reporting and it's going to be a pure cost for the companies. Not really clear for me. I mean,
it's a license to operate, let's put it this way. So meaning that if you don't have it, you cannot even be in business. If that's becoming the model, that in some ways it's
I mean, I think we have to differentiate here standards and regulations. I think regulation is going in that way. Standards, big retail companies are asking more and more for CO2 emissions. It might at some point you are not able to sell your products to a retail chain if you are not able to provide CO2 emissions on that.
Mm-hmm.
Yeah, because and there will also become, let's say, but I want to say it's not all about money. There are, of course, monetary boundaries. It isn't free, but let's say I think like carbon will be taxed, your carbon emissions. So the second thing is one of the things we, let's say, what we learned from the most human and environmental ag was that a big value for the retailer was exposure. So he, of course, he calculated it back to euros, but he said, wait a minute, the last year I had the 3 million free publicity. Mm. So let's say that's and it's not common yet, but let's say that's why we are on a mission also to yes, we have to talk about cost, yes, we have to talk about things, but let's talk about first about value for the customer.
Okay, completely agree. I will just wondering, in the Carol, in the last slide you show about bioprocessing, how to create alternative proteins. Are you working on any project about that, about bioprocessing, or
only on a very small scale? We only wanted to test if there is a process there that is very robust, so that it could actually work without too much energy input on farmers' level. And we have learned that that is possible. Mm. We even learned that at the moment one of our mixing apparatus was broken. We had to fix it, and then the fermentation process has stopped. After we started mixing again, it started also producing again. So that was the biggest thing we had learned, because if I would compare this technique to what is already there, think of solar foods in Finland, or Unibio in Denmark, or Callisto in UK or USA. These are all very sophisticated processes that are actually consuming quite some energy and high quality raw materials. We do not believe that is the basic way to move forward. You have to do it in another way. Otherwise, you're actually converting good material into other good materials. No, you have to be able to upcycle as deep as from as deep as possible towards as high as possible quality proteins.
Okay, completely agree. I mean, we work in some way. I'm interested in this technology to understand but completely agree with you that growth factors and media at the moment are quite expensive and core value, and we are using quite expensive growth factors and quite expensive media to create materials. I think the key on bioprocessing is to lower the prices of the raw materials, of the upstream, I would say, of the upstream process before the bioprocessing. Yes. Yeah. I would be more than interested to hear more about that project. If we can.
I think that's also a topic DSM is as well working on, right, Laura, for bioprocessing and the micro, let's say, lab process grown food area, or alternative food.
Yes, some of my colleagues are working on that as well, really. Yeah. I'm mainly responsible for sustainability in animal nutrition, but there are other divisions of DSM also working in this part as well, definitely. Yeah. And so we can keep in contact on that, because I think it's more to come in the near future. Yeah.
Indeed, I think this topic of energy consumption and also indeed synergies with other sectors, very interesting development. Because as I mentioned before, that in Europe right now, the big driver is the regulatory changes. So Scope 3 reporting, But eventually, for this circular model to work globally, it needs to create value by itself. Let's say because of optimized performance for farmers, by reducing energy consumption, by also creating branding for retailers. And that could be show that the business model needs to be also a integral, a circular one, which makes also very interesting to look at, for example, application in new countries. 2 weeks ago at the Green Day in Amsterdam, we brought together as Vertical Farm Institute and Foodlog, we brought the investors from Nigeria, for example, talking about circular cities in terms of also the food production in cities, circularity, energy issues. And there, for example, there's very interesting, just take Africa as example. The country has a vast amount of resources and land, yet it's also the biggest food importer. So very young population, very fast-paced urbanization. So a lot of opportunities for the overall supply chain need to be more optimized. Food waste need to be reduced. And food security in terms of nutrition and also for employment, all have basically at a starting point. So there offers actually a complete new way of thinking of business models. So not subject to the traditional, let's say, retailer pay, cost, regulatory, but you can really rethink a complete different model. So I'm really inviting, I don't know if we have quite a number of registrants from Nigeria, Kenya. I don't know if they're still here. But I would like to hear your comments if you're still here with us, or to think together, can we together develop an application for other countries where you have this rapid growth, there's a lot of changes can be made at the beginning. I see Memory join back from, Memory should be joining from Zimbabwe. Are you still there, Memory? If you are, please join us. I see a picture. Oh, disappeared. But John and Mercar, what do you think about this question of bring this application to, let's say, outside of Europe?
Well, actually, we are looking into these possibilities. What we do see is that, especially in dense populated areas, let's call them conglomerates, we actually are now capable, because we are still in a growing phase, capable of redesigning this food production system in a way we are combining all these things we spoke of this afternoon. We are actually also looking into that, but you have to keep in mind, and in the end, we are working at a family-owned business that's actually quite small, so we have to be managing all the resources we have our own. But by taking part in this type of sharing of knowledge, we at least can contribute a little bit on ideas, and to think on helping on designing and maybe even starting new businesses. Well, we're always open to talk.
Yeah, you need good partners, let's say. It's we have to be carefully and who is asking us. So because you have it takes some requirements to establish this kind of business. But I see big opportunities, because you can. We have 35 years of experience, and we had a lot of lessons learned. So in a new situation, you can frog leap the existence, the current technology.
Yes, indeed. I think the number of questions we raised today are very valuable to dive further. For example, this alternative protein production next to, let's say, a circular facility where you can reduce significantly the energy consumption, but also the complete resource circularity. Yeah. And that's something really interesting, bring a number of parties together to go into deeper, because that's a complete new area where a lot of synergies can be developed.
Yeah, it's completing a puzzle.
Yes.
Yeah.
I think if I may, what pops up in this series is that companies who are at the intersection of various data flows, they in fact together they can orchestrate a level of information that can create value in the traditional sense. So someone will have to come up with a product, and that product represents value, but the value is being created because of the network of data that is being brought together. And the question is, who is going to pay for this, in fact, public information? But it isn't public, it is private information. The private information is being produced by a network, a kind of spider web network, and the company that actually produces a product such as a completely circular egg, for example, is the one who produces value, as is the case of Kipster with Lidl in the Netherlands. So how do you distribute this value creation from this spider web to the actual producer of that egg? That is a question we have to crack, because that value cannot be created if the spider web doesn't produce the information anymore. And I think this is the key question we have to crack in order to continue to produce these data, and to create a trust to share data.
You're completely right. That is because maybe strange for a feed company, but that's why we invested with the University of the Technical University of Eindhoven, but also with the University of Maastricht in developing new business models to crack that question. Because if we stick to the old paradigms and the old business models, we got stuck. So that's true. Yeah. So we are on the way, let's say, but that's more on a business level and a business model level than on a technological level.
Yeah.
And for instance, we plotted visually how the information flow will be in fattening pigs, and we distinguished 16 earning points. And I didn't put value to it, but places where we had to say it metaphorically, where you could place a cash register.
Yeah, but it is not in your company
it's not in my company. No, it's not only in my company. No,
right, and so you need to create a lot of trust in a spider web organization.
Yeah.
Well, thank you, John and Caro, for your sharing and a lot of good insight. And thank you, everybody, for joining and participating. We are coming to the end of this session, which is the last one before the summer. Maybe, Dick, you'd like to say a few words about what might be in store?
Well, what is in store is indeed this question. This is the question we need to crack, and we saw it through the various business cases we discussed before summer and after summer. We'll be back with new business cases and companies joining. And what we'll be back probably with a physical conference in the Netherlands with handpicked people around the table to crack this question. And I think we should approach, as Pedro said, on a local scale. We'll need to experiment with kind of circular systems that reduce to the max the data you need, and that actually maximize or optimize the output in terms of circularity. So we'll be back with the same kind of cases, all new cases, and we'll try to bring you together in order to be the grease in cracking this question.
Okay. Yeah. No, well, then thank you, everybody, for joining. Have a great summer, and I hope to see you again in a few months.
That'll be in October will be the first one, but you'll all learn about it.
Okay.
Thank you very much.
Thank you.
Thank you, everybody.
Thank you.
Bye-bye.
Thank you.
Bye.